Okay, hi everyone, welcome back to this video series on Windows Server 2012 overview of DHCP. TCP IP is the priority protocol for Windows Server 2012 R2. There are two ways to have clients and servers get TCP IP addresses. You can manually assign the addresses. The addresses can be assigned automatically. Manually assigning addresses is a fairly simple process. An administrator goes to each of the machines on the network and assigns a TCP IP address. The problem with this method arises when the network becomes mid-sized or larger. Think of an administrator trying to individually assign 4,000 TCP IP addresses, subnet masks, default gateways, and all of the other configuration options needed to run the network. DHCP's job is to centralize the process of IP address and option assignment. You can configure a DHCP server with a range of addresses called a pool and other configuration information and let it assign all of the IP parameter addresses, default gateways, DNS server addresses, and so on. Introducing the DORA process. An easy way to remember how DHCP works is to learn the acronym DORA. DORA stands for Discover, Offer, Request, and Acknowledgement. In brief, here is DHCP's DORA process. 1. Discover when IP networking starts up on a DHCP-enabled client. A special message called a DHCP Discover is broadcast within a local physical subnet. 2. Offer. Any DHCP server that hears the request checks its internal database and replies with a message called a DHCP Offer, which contains an available IP address. 3. Request. The client receives one or more DHCP offers depending on how many DHCP servers exist on the local subnet, chooses an address from one of the offers and sends a DHCP request message to the server to signal acceptance of DHCP offer. 4. Acknowledgement. When the DHCP server receives the DHCP request, it makes the IP address as being in use. That is usually, though it's not required. Then it sends a DHCP acknowledgement to the client. 5. When the client accepts an IP offer, the address is assigned to the client for a specified period of time called a lease. After receiving the DHCP message, the client performs a final check of the parameters. Sometimes it sends an ARP request for the offered IP address and makes note of the duration of the lease. The client is now configured. If the client detects that the address is already in use, it sends a DHCP decline. DHCP lease renewal. No matter how long the lease period, the client sends a new lease request message directly to the DHCP server when the lease period is half over. Give or take some randomness required by RFC 2131. The period goes by the name T1, not to be confused with the T1 type of network connection. If the server hears the request message, there is no reason to reject it. It sends a DHCP ACK to the client. This resets the lease period. If the DHCP server isn't available, the client realizes that the lease can't be renewed. The client continues to use the address, and once 87.5% of the lease period has elapsed, again, give or take some randomness, the client sends out another renewal request. This interval is known as T2. At that point, any DHCP server that hears the renewal can respond to this DHCP request message, which is a request for our lease renewal with a DHCP ACK and renew the lease. If at any time during the process the client gets a negative DHCP NAC message, it must stop using its IP address immediately and start leasing process over from the beginning by requesting a new lease. When a client initializes its IP networking, it always attempts to renew its old lease. If the client has time left on the lease, it continues to use the lease until its end. If the client is unable to get a new lease by that time, all functions stop until a new valid address can be obtained. DHCP lease release. Although leases can be renewed repeatedly, at some point they might run out. Furthermore, the lease process is at will. That is, the client or server can cancel the lease before it ends. In addition, if the client doesn't succeed in renewing the lease before it expires, the client loses its lease and reverts to APIPA, which is automatic private IP addressing. This release process is important for reclaiming extinct IP addresses used by systems that have moved or switched to a non-DHCP address. Advantages and disadvantages of DHCP. DHCP was designed from the start to simplify network management. It has some significant advantages, but it also has some drawbacks. Advantages of DHCP. The following are advantages of DHCP. Configuration of large and even mid-sized networks is much simpler. If a DNS server address or some other change is necessary to the client, the administrator doesn't have to touch each device in the network physically to reconfigure it with new settings. Once you enter the IP configuration information in one place, the server is automatically propagated to clients, eliminating the risk that a user will misconfigure some parameters and require you to fix them. IP addresses are conserved because DHCP assigns them only when requested. IP configuration becomes almost completely automatic. In most cases, you can plug in a new system and then watch as it receives a configuration from the server. For example, when you install new network changes such as a gateway or DNS server, the client configuration is done at only one location, the DHCP server. It allows a pre-boot execution environment PXE client to get a TCP IP address from dhcp.e.pxe clients, also called Microsoft Windows Deployment Services clients, can get an IP address without needing to have an operating system installed. This allows WDS clients to connect to a WDS server through the TCP IP protocol and download an operating system remotely. Disadvantages of DHCP. Unfortunately, there are a few drawbacks with DHCP. DHCP can become a single point of failure for your network. If you have only one DHCP server and it's not available, clients can't request or renew leases if the DHCP server contains incorrect information. This misinformation will automatically be delivered to all of your DHCP clients. If you want to use DHCP on a multi-segment network, you must put either a DHCP server or a relay agent on each segment, or you must ensure that your router can forward Bootstrap Protocol BOOTP broadcasts, Ipconfig lease options. The Ipconfig command line tool is useful for working with network settings. Its /renew and /release switches make it particularly handy for DHCP clients. These switches allow you to request renewal of or give up your machine's existing address lease. You can do the same thing by toggling the Obtain an IP address automatically button in the Internet Protocol TCP IP properties dialog box. But the command line option is useful, especially when you're setting up a new network. For example, I spend about a third of my time teaching MCSA or MCSE classes, usually in temporary classroom setup at conferences, hotels, and so on. Laptops are used in these classes with one brainy way to, with one set up as a DNS DHCP DC server. Occasionally, a client will lose its DHCP lease or not get one, perhaps because a cable has come loose. The quickest way to fix it is to pop open a command line window and type ipconfig/renew. You can configure DHCP to assign options only to certain classes. Classes defined by an administrator are groups of computers that require identical DHCP options. The setclassid classID switch of Ipconfig is the only way to assign a machine to a class. More specifically, the switches do the following: ipconfig/renew instructs the DHCP client to request a lease renewal. If the client already has a lease, it requests a renewal from the server that issued the current lease. This is equivalent to what happens when a client reaches the half-life of its lease. Alternatively, if the client doesn't currently have a lease, it is equivalent to what happens when you boot a DHCP client for the first time. It initiates the DHCP mating dance, listens for lease offers, and chooses one it likes: ipconfig/release. Forces the client to give up lease immediately by sending the server a DHCP lease notification. The server updates its status information and marks the client's old IP address as available, leaving the client with no address bound to its network interface. When you use this command, most of the time, it'll be immediately followed by ipconfig/renew. The combination releases the existing lease and gets a new one, probably with a different address. ipconfig/setclassid classID sets a new class ID for the client. You will see how to configure class options later in this section. Setting scope options for IPv4. For now, you should know that the only way to add a client machine to a class is to use this command. Note that you need to renew the client lease for the class assignment to take effect. Understanding scope details. By now, you should have a good grasp of what a lease is and how it works. To learn how to configure your servers to hand out those leases, however, you need to have a complete understanding of some additional topics: scopes, superscopes, exclusions, reservations, address pool, and relay agents. Scope. Let's start with the concept of a scope, which is a contiguous range of addresses. There's usually one scope per physical subnet, and the scope can cover a Class A, Class B, or Class C network address, or a TCP IPv6 address. DHCP uses scopes as the basis for managing and assigning IP addressing information. Each scope has a set of parameters or scope options that you can configure. Scope options control what data is delivered to DHCP clients when they're completing the DHCP negotiation process with a particular server. For example, the DNS server name, default gateway, and default network time server are all separate options that can be assigned. These settings are called option types. You can use any of the types provided with Windows Server 2012 R2, and you can specify your own. Superscope. A superscope enables the DHCP server to provide addresses for more than one scope to clients on the same physical subnet. This is helpful when clients within the same subnet have more than one IP network and thus need IPs for more than one address pool. Microsoft's DHCP snap-in allows you to manage IP assignment in the Superscope, though you must still configure other scope options individually for each child scope. Exclusion and reservations. The scope defines what IP addresses could potentially be assigned, but you can influence the assignment process in two additional ways by specifying exclusions and reservations. Exclusions. These are IP addresses within the range that you never want automatically assigned. These excluded addresses are off limits to DHCP. You'll typically use exclusions to tag any addresses that you never want the DHCP server to assign at all. You might use exclusions to set aside addresses that you want to assign permanently to servers that play a vital role in your organization. Reservations. These are IP addresses within the range for which you want a permanent DHCP lease. They essentially reserve a particular IP address for a particular device. The device still goes through the DHCP process. That is, its lease expires and it asks for a new one, but it always obtains the same addressing information from the DHCP server address pool. The range of IP addresses that the DHCP server can assign is called its address pool. For example, let's say you set up a new DHCP scope covering the 192.168.1 subnet. That gives you 255 IP addresses in the pool after adding an exclusion from 192.168.1.240 to 192.168.1.254. You're left with 241.255.14 IP addresses in the pool. That means, in theory at least, you can service 241 unique clients at a time before you run out of IP addresses. DHCP relay agent. By design, DHCP is intended to work only with clients and servers on a single IP network to communicate, but RFC 1542 sets out how BOOTP on which DHCP is based should work in circumstances in which the client and the server are on different IP networks. If no DHCP server is available on the client's network, you can use a DHCP relay agent to forward DHCP broadcasts from the client's network to the DHCP server. The relay agent acts like a radio repeater, listening for DHCP client requests and retransmitting them through the router to the server. Installing and authorizing DHCP. Installing DHCP is easy using the Windows Server 2012 R2 installation mechanism. Unlike some other services discussed in this book, the installation process installs just the service and its associated snapping, starting it when the installation is complete. At that point, it is not delivering any DHCP service, but you don't have to reboot. Installing the DHCP service. Choose Server Manager by clicking the Server Manager icon on the taskbar. Click Add Roles and Features. Choose Role-Based or Feature-Based Installation. Click Next. Choose your server. Click Next. Choose DHCP and click Next. Add the feature screen. Click Next. Click Next at the DHCP screen. At the DHCP screen confirmation. At the DHCP confirmation screen, click the Install button. When the installation is complete, click the Close button. On the left side, click the DHCP link. Click the More link next to Configuration Required for DHCP Server. Under Action, click Complete DHCP Configuration. At the DHCP description page, click Commit. Click Close at the summary screen. Close Server Manager. Introducing the DHCP snap-in. When you install the DHCP server, the DHCP snap-in is also installed. You can open it by selecting Administrative Tools, DHCP. Figure 217 shows the snap-in, and as you can see, the snap-in follows the standard MMC model. The left pane displays IPv4 and IPv6 and IPv6 sections and which servers are available. You can connect to servers other than the one to which you're already connected. A server options folder contains options that are specific to a particular DHCP server. Each server contains subordinate items grouped into folders. Each scope has a folder named after the scope's IP address range. Within each scope, 4 subordinate views show you interesting things about the scope, such as the following. The address pool view shows what address pool looks like. The address lease view shows one entry for each current lease. Each lease shows the computer name to which the lease was issued, the corresponding IP address, and the current lease expiration time. The reservations view shows the IP addresses that are reserved and which devices hold them. The scope options view lists the set of options you've defined for the scope. Authorizing DHCP for Active Directory. Authorization creates an Active Directory object representing the new server. It helps keep unauthorized servers off your network. Unauthorized servers can cause 2 kinds of problems. They may hand out bogus leases, or they may fraudulently deny renewal requests from legitimate clients. When you install a DHCP server using Windows Server 2012, 2012 or 2, an Active Directory is present on your network, the server won't be allowed to provide DHCP services to clients until it has been authorized. If you install DHCP on a member server in an Active Directory domain or in a standalone server, you'll have to authorize the server manually. When you authorize a server, you're adding its IP addresses to the Active Directory object that contains the IP addresses of all authorized DHCP servers. At each start time, each DHCP server queries the directory looking for its IP address on the authorized list. If it can't find the list, or if it can't find its IP address on the list, the DHCP service fails to start. Instead, it adds a message to the event log indicating that it couldn't service client requests because the server wasn't authorized. Exercise 2.8 and exercise 2.9 show you how to authorize and unauthorize a DHCP server onto a network with Active Directory. If you installed DHCP onto a network with a domain, you can complete the following 2 exercises, but if you are still on a member server, you cannot do these exercises. These are here to show you how to do it after you have Active Directory on your network. Authorize a DHCP server. 1. From Administrative Tools, choose DHCP to open the DHCP snap-in. 2. Right-click the server you want to unauthorize and choose the Unauthorized command. 3. Click Yes on the dialog box asking if you're sure you want to complete this section. Okay, Unauthorizing a DHCP server. 1. From Administrative Tools, choose DHCP to open the DHCP snap-in. 2. Right-click the server you want to authorize and choose the Authorized command. 3. Wait for a short time, 30 to 45 seconds, to allow authorization to take place. 4. Right-click the server. Again, verify that the Unauthorized command appears in the pop-up menu. This indicates that the server is now authorized. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.